Hey there, buddy. We are continuing on in this video with the 2-2 through 2-5 practice. So row number 4 is x minus 1 a factor of f of x? So to determine if it is a factor, when you divide a number, like let's say we have 30 divided by 5, we get 6 with no remainder, which means that 5 is a factor of 6. And we also can know that if I have our divisor times the quotient, it equals the dividend. So keep that in mind when we go through this problem. So what we're going to look for is to see if x minus 1 is a factor, then the remainder will be 0. So the easiest way to do this, since this is a linear factor right here, we can do synthetic division. And so think to yourself, what goes in the little box here? And it would be a positive 1. And then we have the coefficients of 2, 3, -8, and then the constant is 3. And notice there aren't any missing terms, so I didn't need to worry about that, but be watching for that. So we bring down our 2, we multiply 2 times 1 and put the result over here, and then we add. So then we keep going through that process. 1 times 5 is 5, -8 and 5 is -3, 1 times -3 is -3, and we get 0, and this is our remainder. So the factor theorem tells us that if we have a remainder of 0, that yes, x minus 1 is a factor of the polynomial f of x. Okay, so the first part is done. So yes, it is a factor. If I had you say, explain why, you would say because the remainder is 0. And so this is our quotient right here. And remember, this is the constant term, the x term, and the x squared term. So the quotient is 2x squared plus 5x minus 3. Now, just like I had when I divided 30 by 5, we got 6, and 5 times 6, so the divisor times the quotient is equal to the dividend. So if this is my quotient and this was my divisor, then f of x, we can start factoring it. We know that x minus 1 is a factor, and if I multiplied it by the quotient, I would get this. If I multiplied x minus 1 through to this trinomial here and simplified everything, I would get that original function back. So we've partially factored this, and to find the zeros, that's what we need to do. We need to factor it completely and then set each factor equal to 0. So now we have this x minus 1, and now we have a trinomial, and the trinomial we can factor straight up. So we know that it has to be a 2x and an x if it's factorable. And we know we need a positive 5 in the middle, and we need to have the last two terms have to multiply to -3. If I put a 3 here and a 1 here, I'm going to get a 6 and a 1, which I can get a 5 out of because 1 has to be plus and 1 has to be minus. And since it's a positive 5, I want to have it be a positive 6 minus a 1x in that middle to get the positive 5. Oops, I just wanted to get rid of this little line right here. Okay, now we're completely factored. That is completely factoring the polynomial because we are down to linear factors. And when you have a linear factor, it is prime. And so what you do is you set each factor equal to 0 and you solve it. So x minus 1 is 0 when x equals 1 by adding 1 to both sides. 2x minus 1 is equal to 0. Add the 1, you get 2x is 1. Divide by 2, x is 1/2 is another 0. I'm going to circle these guys. And then x plus 3 is equal to 0 when x is -3. So my factoring it completely is this piece right here, f of x was equal to x minus 1 times 2x minus 1 times x plus 3. And one main reason you'd want to do that, factor it completely, is to find those zeros. And our zeros, we have x equals 1, x equals 1/2, x equals -3. So we're going to look at that graphically. Okay, so if we trace here and look at, okay, the zeros were -3, there's one of them. So zeros are your x-intercepts, which is also where your y value is equal to 0. And then I think what, we had another one at 1/2. So if I trace to 1/2, there's the other 0, you can see that flashing there. And then the other one was at 1. And you can see that other 0. So that's what we're finding. What are the x-intercepts of the graph? And if you get if you get a 0, excuse me, that is not a real number, like it involves the square root of -1 or I, which is what we're going to go into next here, that means that it still makes the function equal 0. However, graphically, it won't actually show up as an x-intercept. So it's kind of unique. Okay, but anyway, let's talk about complex numbers. Recall, these are two main things you need to know. The square root of a -1, they used to think it was imaginary because you can't multiply any number in our real number system by itself and get a negative number. 1 times 1 is 1, -1 times -1 is also 1. So, first they thought they were imaginary numbers, and they called them imaginary. And they're represented oftentimes with the letter I for the imaginary unit. That's called the imaginary unit. But they're used in all kinds of different places. And electronics is a main one, or a big one, I should say, not a main one. There's lots of different applications. In electronics, however, the letter I is not generally used. It's usually the letter J. I forget why. I think I is reserved for current, so I think the reason why. Okay, but then if you think of this, if you square both sides here, you end up with I squared. The square undoes the squaring, and you end up with I squared is equal to -1. So these are two things you need to know. Put a box around that one. Okay, so I squared is -1. And the square root of -1 is I, so let's simplify the square root of -64. We can split that into the square root of 64, which is actually a perfect square, and multiply by the square root of -1. The square root of 64 is 8. The square root of -1 is I. So the way that you would write the square root of -64 in simplified form is 8I. Okay, so sometimes when you're finding zeros of a polynomial, you end up with I in the answer. I'm just going to do a little, which is why we're reviewing this right now. I'm going to do a little bit more computation though here with I. Multiply and simplify. I have two complex numbers. Complex numbers are in the form A plus BI. A and B will be real numbers. So these are two examples of complex numbers, 5 plus 2I. The A in that case is 5, the B is 2. This is the real part, and the 2I is the imaginary part. Together, it makes up a number called a complex number. 3 minus 4I is also a complex number. We're going to multiply two complex numbers together and look at what happens here. So we just FOIL just like normal. You're going to multiply the real part of this first complex number times both the 3 and the -4. So 5 times 3, that's 15. And I'm going to distribute to the -4. I get a 5 times a -4 is -20I. And then moving to the 2I, because I'm done with the 5. So 2I times 3, it's positive 6I. So we're going to combine those, our like terms in a minute. And then the last two, 2 times -4 is -8, and then I times I is I squared. And recall what I squared is. Remember, it is -1, so we're going to substitute in a -1 for that. So I have 15, adding -20 to 6, I get -14I minus 8 times -1. I get 15 minus 14I plus 8, because I have the two negatives. 15 and 8 is 23. So my simplified result is going to be 23 minus 14I. Okay. So let's do one more here. Back up here, when you're factoring and finding zeros, we had factors of x minus 1, and to find the 0, we set it equal to 0, and we added the 1, and we ended up with x equals 1 is our 0. So notice that when x equals 1 is a 0, the factor is x minus 1, x minus the 0. So when you are doing number 7 here, and you're writing a cubic function, which means third degree, and it has these zeros, you're going to find the factors of f of x by taking x minus the 0. So x minus 0 of 2, so it'll be x minus 2. And then x minus a negative 1 becomes x plus 1. And x minus 4 is x minus 4. So you guys go ahead and multiply this through and then simplify it by combining your like terms. Okay, so when you finish multiplying through and simplifying, you should get f of x is equal to x cubed. Make sure you show all your work on here before you submit this assignment. X cubed minus 5x squared plus 2x plus 8. So if you didn't get that, go through and look at this. What I did is I multiplied this x plus 1 times this x minus 4. After simplifying, I got x squared minus 3x minus 4. And then I multiplied x, there's a purple here, I multiplied the x through, and I got x cubed minus 3x squared minus 4x, and then I moved on to the orange part here, which I had to distribute the negative 2. You get negative 2x squared. Negative 2 times negative 3 is negative 6x, and negative 2 times negative 4 is plus 8. These are like terms, so I combined those. Negative 3x squared minus 2x squared is negative 5. Oh, there were no other x cubed terms, so I just left that one. And then minus 5x squared, and then I have this guy and this guy. Negative 4 plus 6 is 2x, and then plus 8. Okay, let's just finish this up here. So the fundamental theorem of algebra has a lot of meaning, but it's really quite simple. According to the fundamental theorem of algebra, a polynomial of degree n, so if its degree is n, it has exactly n complex zeros. Some of them might involve I, and some of them might be real. But if you factored it completely, you would find that you would have exactly n zeros for an n degree polynomial. So if you have a fifth degree polynomial, there will be exactly 5 zeros. If you have a 8th degree polynomial, you'd have exactly 8 zeros. That's what the fundamental theorem of algebra tells us. And then the last little piece here, if 3 minus 6i is a 0 of a function f of x, then so is what's called its complex conjugate, which is 3 plus 6i. So anytime that you have a complex root or a complex 0, then it's going to have a mate. It's going to have a pair, and its pair will be, the real part will stay the same, but you do the opposite on the imaginary part. And so that is a very quick review of 2.2 through 2.5. And then the next thing we're going to do, well, we'll go over questions. Bring any questions that you have. If you didn't understand parts of this or anything, let me know. We'll go over it, and then we will move on to rational functions, which is the next part of our lessons. Okay.